Hi, this is James Cook of the University of Maine at Augusta, and I'm recording this video for the social science program as a sociologist to talk about some ways to conduct a flexible, very basic and elementary sentiment analysis in R, something that you can use for a variety of pieces of content using a method that's been around for longer than you might think. So if we look at computer scientists and their ideas about sentiment analysis and the history of it, how long it's been around, they'll indicate either the early 2000s or perhaps 1997 for actual sentiment analysis of texts using an algorithmic process. And then they might, as Devopedia does here, say, well, there were some earlier, really ancient versions of this, like public opinion polling as sentiment analysis, or heck, ancient Greece. But there's something in between ancient Greece and just polling of publics in surveys, and then the computer science focused idea of sentiment analysis, and that is the considerable 20th century history of social science sentiment analysis. And that really goes back in no small part to a piece of work in 1962 by a number of behavioral scientists, social psychologists, who are trying to figure out how can we take these new things called computers, which were really quite rare and quite large and quite rudimentary at the time, and how can we begin to take words in a text and understand sentiment in a systematic, algorithmic way, where an algorithm is an exact plan that doesn't rely upon gut feelings, but instead relies upon some standard. In this case, Philip Stone and colleagues, working with a grant from the National Science Foundation, develop the idea of a general inquirer. Now, they're all, as social psychologists, working at Harvard University. And so what they develop in this general inquirer system is a Harvard dictionary of sentiments that are associated with different sets of words. And they create a dictionary that involves positive sentiment and negative sentiment, assigned to stables of very clear words that consistently head in one way or another. Now, they talk about using IBM cards and sorting machines in order to run a computer program. And these days we have something a little bit more fast and speedy and reliable. But the idea is essentially the same. And the truth is that the general inquirer system is still around. There are 452 citations to this piece of fundamental work that stretch all the way from 1963, the year after the development of this work, to 2023, the year that I'm recording this video. And those are only direct citations. There are over 7,000 published peer-reviewed pieces of research that use the general inquirer system, which is still around with its Harvard Dictionary, now the Harvard 4 Dictionary. One of the first ones of these pieces of sentiment analysis that didn't need to wait for the development of computer science, but was carried out by, again, social psychologist Gordon Allport, who's famous for ideas of intergroup relations and prejudice. He also published this analysis using the general inquirer system and the lexicon of positive and negative words, in addition to some psychological associations beyond what we'll do today, in order to compare and contrast what clinicians on the left of this really old school table 5 saw in this patient's letters, this quote-unquote Jenny, a pseudonym, who had 172 letters analyzed by clinicians, and then used the general inquirer system in order to generate a series of outcomes, a series of categories of characteristics, and found that a number of them corresponded. You can read them if they're on the same line. They're reading from left to right. There were a few differences, and the terms were a little bit different, but they corresponded, and that was Allport's point when he published this piece of work in the American Psychologist in 1966. So we're going to update that, and we're going to talk about not card sorting systems, but today we're going to talk about using the free, as in free beer, and open source software package called R, which is developed for researchers, methodologists, statisticians to do their work. And we're going to be using what's called an integrated development environment called IDE, called RStudio, and I have links here for where you can download these for free. First install R, then install RStudio. The IDE provides a consistent experience across all platforms, and it offers some nice debugging tips, hints that that are color-coded about errors and things like that. And then we're going to use some packages that allow us to extract content from different places in social media, so that we can get that text. One which is Reddit Extractor, which is for Reddit, and then Voson SML we're going to use to extract text from YouTube. For analysis, we're going to use Sentiment Analysis, a package, all one word, and that package uses the General Inquirer dictionary developed from Harvard, particularly the one that indicates the positive or negative sentiment of either words or passages of words. And then we're going to be using GGP MISC. GG here refers to the grammar of graphics, and so GGP is an extension to ggplot, which we'll see in visualization below, which allows for the inclusion of actual statistical analysis on the fly, displayed in a graph. And we're going to display some of that analysis through ggplot, which is all about plotting graphics for research that are consistent and systematic in how you describe them. And then iGraph, which is a package that is used to describe social networks, relationships between elements. In this case, it'll be relationships between ideas. The dictionary that we're going to use for the sentiment analysis is the Harvard 4 dictionary in the General Inquirer system. And one of the neat things about this video, comparing it to previous videos, is that in previous videos I was telling you about how to grab data from Reddit, how to grab data from YouTube, how to go out and create your own descriptive cultural network once you have a text, and to put that in a particular format in an Excel spreadsheet. Each of those was particular to the subject, but one of the really neat things about the package Sentiment Analysis is that it can be used for almost any text source, whether that is a YouTube video and comments to that video, or whether it's a Reddit discussion board forum and a set of comments to a discussion board post. You can use the same commands and the same approaches to describe each. And most interestingly, if you craft your own list of cultural associations, as we do with the bimodal semantic networks, you can also use sentiment analysis then to indicate not just meanings, but the valence of the meanings. Are they positive or negative meanings? And what I have here is a set of 3 videos that if you want to look at that prior work to get the content, are on my YouTube video channel. Just search for these italics texts. I'll also post in the comments direct links to each of these works. So let's take a look at how this dictionary works, this general inquirer, and how we can apply it to a variety of texts from different sources. To first be able to run a sentiment analysis, we're going to need to load the package sentiment analysis. And in order to do that first, anytime we're going to load a package, also called a library, we're going to need to install it first under the tools, install packages command. I've already done that, so I'm going to hit cancel, but you would type in sentiment analysis there to load and install on your computer the package sentiment analysis. Then to look at the dictionary that is included in the sentiment analysis package called Dictionary GI, the one that we're interested in. The other ones right now in that package are mostly financial terms, and that's fine for an economist, but I'm a sociologist. We're simply going to call Dictionary GI and ask to take a look at it. So let's run that very simple code, and look, immediately it's right here. Let's take a look and see what it looks like. Scrolling up to the top, we can see right away that there are some negative words, and those words are placed in quotes, and they are the sort of words that you imagine would be negative, like blackmail, blockhead, agonize, aggrieve, abhorrent, abscond, absurd, and abominable, just to quote the A's. And then it's not going to show them all because we're going to be truncated for space concerns, but there are 1,005 more beyond the 1,000 that are shown here. And then there are positive words like accuracy, admire, adore, adjunct, ability, accompaniment, allied, amazing and amiable, and so many more. So the Harvard 4 Dictionary is the work of these social scientists who have continued to hone their list of positive sentiment words and negative sentiment words. So, with that in mind, let's start to figure out how to use that package and use that dictionary. And let's start with some YouTube data. Now, we'll select a script that's partially started. I've loaded a number of packages, each of which need to be installed, that will collect data. Tidyverse and Vosen SML together work to collect YouTube data in lines 9 through 13. If we removed hashtags and we entered an API key that you could obtain for yourself for free, you could then collect data for a particular video. I, again, have already recorded that process, and you can see in the comments to this video what video you can watch to figure out how to get that API key and how to then collect YouTube data. So let's move right ahead to step 2. And in step 2, what we can do is start working with the data. And there's some processing that we're going to need to accomplish. Let's look at the data first. So it's over here. It's called YouTube data. And I'm going to click on it. And the first thing I need to do is find the content that I want to analyze the sentiment of. And for me, it's the text of the comment itself. That's what I want to look at. And so the name of that column is comment with a capital C. So it's important in R to mention the capital and not just the lowercase. The case matters. So I want to then make sure that any funny business that was put in is taken out. By funny business, I mean special characters that will confuse the sentiment analysis package, or like emoticons. This is not an emoticon analyzing piece of work. So I have to make sure that those comments are in readable text format. What's more, I might want to look at some other variables like reply count and like count that indicate how many replies a comment got and how many likes it got. But one of the funny things is that sometimes when the data is collected, it looks like a number, but it might be a string. So this is just pre-processing to make sure everything is set up just about right. So I'm going to write in a few comments here, or commands, to just get the data ready. So I'm going to say, let's take YouTube data, and we want to make some changes to it, okay? And particularly, let's make changes to the comment column. To select a particular column or make changes to a particular column, you name the data set and then put a $sign and then the name of the column. So what do I want to do to it? Well, I want to take that same piece of information, YouTube data, comma, that same column, and I want to do something to it. What I want to do is I would like to encode it, and I'd like to encode it to UTF-8, which is a universal text format that is just easy to read all the time. Excuse me. And so I'm going to then want to make sure that the counts are in the right format as well. And so to do that, I'm going to want to, again, work with YouTube data. And here I'm going to want to select reply count. And what do I want to do? I just want to make sure that it's named as numeric. I want it to be as numeric. And what would I like that to be? YouTube data, reply count. I'm just making sure that it's going to be in the right format. And I'm going to copy that line. And then I'm going to do the same thing except for like count. And again, like count. Okay, so wonderful. Now I'm ready actually to run a sentiment analysis, and there are things I'd want to do later to display some results, but running a sentiment analysis is really just as simple as naming a placeholder for your results. I'll call it YouTube sentiment. And then what's it going to be? Well, that arrow says it's going to be that. I just need to use the phrase or the command analyze sentiment. And what do I want to analyze sentiment for? I want to analyze the sentiment for YouTube data comment. I mean, what could be simpler? It's going to run it. And then I'd like to bring that piece, that object sentiment, YouTube sentiment, and I'd like to put it in as a column in with my old YouTube data. So let's do that. And the way to do that is to bind the columns. It sounds kind of like something out of a J.R.R. Tolkien movie, doesn't it? But really, it just means you put them together in the same order that both were in. Unfortunately, full YouTube data, okay, so that's meaning all of it, okay, is going to be what I have in those two sets stuck together using the bind calls for bind columns command, which is going to have two options. The first is the first piece I want to put together, and the second is the second piece I want to stick onto it. Okay? That's not hard at all. So now, what that does for me is runs a sentiment analysis, generates some information about it, and then puts these two pieces of information together so that I can not only look at one variable of content material, but I can also then think about how the sentiment that is apparent in a comment might be related to some other features of the comment, like the number of replies or the number of likes. So let's run this program so far and see what we get. Okay? All right, so I'm just going to run those selected lines, and I've selected them all, and hopefully it'll work just fine and I won't have a typo. And it's done. That didn't take very long, mostly because I didn't have to collect the data already. And now I can look at, let's do that. Let's view, typing this in the console, which you can do every now and then. Full YouTube data. Let's take a look at it. Okay, so now we have the comment. We have all that material, the author's name, their image, the reply count, the like count, the timestamp, which is nice to know when it was, the word count. Oh, that's interesting. And then there's this sentiment GI. So this is a number that is negative when sentiment is tends to be negative when a lot of negative words are used in the comment, and it's positive when a lot positive words are used in the comment. And the more positive or the more negative it is, with a maximum of -1 or +1, the more net positive or net negative that comment is. And then there's materials for other dictionaries as well, but these tend to be financial dictionaries, in which I'm simply not interested. So we've bound them all together, all this data, that's lovely. And now I'm ready to work with it, and I'd like to visualize it with some plots. And the first kind of plot that I'd like to put together is a histogram. Now, one of these libraries that I'm using here is called ggplot2, which is a general grammar for graphics, which is a set of consistent commands to be able to easily create a nice chart. And then ggpmisc it allows me to add a little bit of statistical analysis in to say, hey, I'd like to do something like plot a best fit line, and I'd like to see the equation for that line, because I like those equations. I like regression lines, and an r-squared, which tells me how much of the variation is explained by that line, as opposed to it being really a bunch of diffuse dots. But that's going to let us do, to start with, a histogram. So to run a histogram, or any plot, we're going to start with ggplot. And then we just need to note some options. The first is, well, what are we going to plot from? It's going to be from full YouTube data. And then we need to specify what it is that we'd like to plot, what variable. And so this is just something you have to know. You're going to be plotting AES, in which the x-axis, which in this case really is the only axis because the y-axis is going to be counts, is going to be sentiment GI. And then we'd like to tell it to work with that material and create a geometric form. What geometric form? You notice these are all kinds of plots here that are possible. We want the one that is a histogram. And a histogram simply says how many of a certain range of values occurs. So how many negative, really negative values, how many sort of negative values. And let's just do that. And let's then add some labels. And the shortened version for labels is, here is labs.
And the labs that we want to add is a nice title. You know, if we were doing this for an academic paper, we could say figure 1, but I'm just going to say title equals sentiment histogram for YouTube video. You know, it's just describing what it is. And then we're going to want to make sure now, since there have been a lot of parentheses, that we have 1, 2, those 2 are taken care of. Whenever there's a beginning parenthesis, we want an end parenthesis. There's another beginning parenthesis and an end parenthesis. Wonderful. So once I've done that, I can, let's just run that. And I'm going to do that by selecting it and then running that selection. Let's see what it brings us. Oh, so I have a small problem. It's a typo. You always need to add parentheses, even if you don't put anything into it, to geom, histogram, or any geom, any geometric form. Silly me. Everybody makes mistakes all the time, but that's what that error code reminded me of. And now I can run it. I'm just going to run that selected line. And that's great. We have a sentiment histogram that's telling us that we have, for this YouTube video, a peak at around neutral, and a bit of a skew over toward the positive. More positive words than negative words. That's lovely, and a nice title at the top. But you know, we might want to do more than that. We might want to, I don't know, if we wanted to perhaps be following the temporal trajectory of sentiments, is there a pattern where sentiments go particularly up and down on particular days? And there was a timestamp. It was called published at in the data. So we can do that, and we can start with just another ggplot. But this time, although we're going to work again with full YouTube data, we're going to set up a different plot. And this time we're going to have an X and a Y. So these are axes, and our axes are, what are axes? Our X is going to be perhaps, what do we want it to be? The x-axis should be dates, right? So that would be X equals published at, and Y will be the column sentiment GI. Okay, so that looks good. And then, oh, we need to tell it that we want it to be a bunch of points, a scatter plot. Geom point to create scatter plots. So we'll do that. Okay, and I am going to get my lesson learned and include those parentheses. And then let's add a label. And that will be title equals scatter plot of sentiment by date. And it looks all good to me. So let's run that line now. I mean, so this is really pretty easy, isn't it? We're just running a set of plots on variables that we think might be, you know, they could possibly be related. And now I'm seeing, you know, it looks like a fair amount of variability to me. That on most days there's more positive than negative sentiment, which we saw in the histogram, so we shouldn't be surprised. And there doesn't really seem to be an overall sweep up or down. That's fair. So let's continue to move on, and whoop, I moved between tabs. Okay. Now, what if the number of likes a comment has is associated with the sentiment? That perhaps the sentiment of a comment, if it's more positive, gets more likes. I mean, it's possible. So we could do just yet another scatter plot, right? And in this case, we could literally now cut and paste that scatter plot, and instead of published at, we could instead have it be the x-axis be like count. That would be nice. And then we could do the same, and we could see what kind of pattern that there might be regarding reply count. Maybe a sentiment gets more replies when it's really negative. It's a hypothesis, isn't it? And we could just run that scatter plot and take a look. And well, why don't we do that? And I'll run those lines. Now, a problem with the scatter plot is what happens when there's a lot of scatter plots that are just in the same general area, right? They're all bunched up against each other. And so it's hard to tell exactly how many there are. So I'm not exactly sure what I see here. What I see is actually a lot of comments that are have very few likes, and very few that have a lot of likes. And the ones that are very few have all kinds of sentiment. And I don't know which ones are where, either for the like count or the reply count. And by the way, I'm noticing I would need to change the title to like count and reply count in order to be able to differentiate between the two. I'll just run it again and replace them. There we are. Scatter plot of reply count by date. I don't know exactly what's going on. I see there's a bunch, but I can't really figure out the trend. And I also can't figure out how many dots there are in there. So what I really want is something with more detail. So in order to do that, I want a different kind of plot. And I'd also like to know what the general pattern is. Remember I said I want something like a best fit line? So I'm going to do now a bit more of a fancy plot. And it's going to be a GG plot, again, the grammar of graphics to plot some graphics. And it's going to be that full YouTube data. Again. And we're going to have axes of like x equals like count. Your x-axis. The y-axis is sentiment. GI, that sentiment score. And now, though, as I work on this, I want a new kind of geometric form. And I want to have a kind of a hexagonal shape, which is going to have different color based on how many of those dots are in that little hexagonal space. So to do that, I'm going to get a geometric point of a hex, okay? So the bins that we're going to set are just basically saying how large that hexagon is. I'm going to set that to 20. And I'm going to set that color equal to white to begin with. But then I'd like to fill it with some other things, okay? So what do I want to fill it with? Well, as we move into a more complicated plot, one of the things that we can do is that we can add that little plus to indicate that there's some material that's continuing the GG plot, but now we'll put one option per line. And in order to continue, then, we're going to fill this thing, this hexagon, with something that's a gradient. And what should it be a gradient of? Let's say low could be green, okay, and high could be red. You get to decide. Maybe that green is a little much, and we want a deep blue, but the blue is shining out a bit too. So why don't we go? Let's stick with green, and the high point is going to be red. Well, that's our gradient, and it's going to have everything in between. Oh, and let's put in a label. our good old labs, our labels. And we'll call that title a density plot of sentiment in YouTube video comments by the number of comment likes. And that'll be our title. Now, I want to add one more piece. Well, we could stop there, and let's run that for now and see what it would look like. Oh, I had a typo. These things happen. There's a V in YouTube data that shouldn't be there. Okay, so I'm going to get that console out now, and let's give that another go. And what did I do here? Cannot use plus with a single argument. Did I accidentally? I put the plus on a new line. Let's put the plus on the old line. Silly me. These little things, these little details, just really, computers care about them. I feel like I don't, but if the computer won't make it work, then I won't be happy. So let's try that again. It says don't put the plus on the new line. So fine, I'll put it on the old line. And there we go. That wasn't too hard. And oh look, now I have an indication of where a lot of the dots are, and where a lot of the dots aren't in this hexagonal surface. I could have picked a different shape, I suppose, like squares or things like that, but really I can see where it goes from green to red. I could change that, I could change the color and say, ooh, what about yellow to red? It's kind of like a fire, right? And I could change that and run it and just experiment with the way I like things. Oh, that's nice. And then you could even go in here and you could figure out, could I do light blue? No. Well, it's not indicating that I can. Although if I put it as one word, then I see that I can, right? And these are the sort of things you might want to just experiment with, just to see what looks nice once you get the basic functionality going. Oh, that's kind of nice. It's a little casual. We see where some are as it emerges there. But now I'd really like to see what the general pattern is, the best fit line, as our teachers used to say in high school, and the regression line, as we would say in statistics now. And the way to do that is to do geometric smooth. They are, I would like to create a nice smooth line. Okay. And what do I want to do that for? I want a linear model. And the neat thing here is that then I get to describe the kind of the polynomial I want. Whether I want just to have the x versus the y, or whether I'd like to allow the curve to have a squared term or a cubed term, or more than that. And the way to do that is with the formula option, and that is where you say y, and then you say, okay, we're going to set y to be, this is just something you have to know, the polynomial, I'll just say, we'll take it up to a second polynomial. And I'm already seeing that I have a little bit of, there we go. I had a little bit of problem with parentheses. I could take the x up to 3 if I want an additional ability to curve. If I didn't want any of those, I could just say, I just want a straight line y to x. And then I want to have a little bit more. I would like to have a description of the regression line, so I know what the line is representing in terms of values and predictions, because that allows you to plug in different values of one of the variables to get the predicted value of the other variable. That's really what a regression line is, by the way. So we're going to do an equation where AES label. This is just a formula that you need to know. And I'm just going to type it in. It is something that I've just learned to not look at too deeply. Okay. And then let me check these. Okay, so we have 1, 2. I think I have too many. Okay. 1, 2, 3. No, I'm good. Good. Excellent. And the formula. I'm just going to put this on a new line because it was going to extend outward. I'm reminding this is y equal the essentially an equals. It's okay going to be set to x here. Excuse me, not poly, but y is in its relationship to x. And then we want to know whether to display it. And of course, that was the whole point of this. Now, it's possible that I got these little dots wrong, which are describing what to put where and just how to label it. But we'll find out. Oh, lovely. No, it's working very well. What it's telling me is two things. First of all, that there's a very mild positive slope to this best fit line, so that the greater the like count, the higher, the more positive the sentiment. But that as we move out from that 0 point of likes, that very quickly the error range, which is that light gray zone, gets really big, so that it's really not a very trustworthy pattern. It could just be 1 or 2 observations that's throwing it off, and we know that by looking at the adjusted r-squared, which is less than 0.01. To interpret an r-squared, you say, oh, the r-squared multiplied by 100 is the percent of the variation in the dependent variable, which in this case is sentiment GI, that is explained by variation in your independent variables, which in this case there's one of. I could mess around and say, oh, well, let's do something with squared terms, allow it to have squared terms for x up to the second power, and then I need to change that again in the formula that was described below. And I could do that, and I could see if there's a magic, curvilinear relationship, although it sure doesn't look like there is one. No, not really much of one. I mean, this is just getting it to fit that outlier a little bit better, and the r-squared is what I really want to pay attention to. This is explaining less than 1% of the variation. It's not a really significant relationship here, right? What's happening is that there's really just very few observations at large like counts, and so it's not trustworthy. But now what if I wanted to do the same thing for the number of replies to the comment? Well, here's the great thing. Once you have a working plot, you can just copy that and paste it down to your next section and just change the variable. We're changing the x variable to reply count. And we probably do want to change the title. And lo and behold, when I select that and run that selection, I have now a second density plot. And it's got a different equation where y is equal to sentiment gi and x is equal to reply count. And now there's an x squared term because I allow that to happen. But still, it's really not a big deal in terms of any relationship. It's nothing that you would write home about. There doesn't seem to be a relationship between the number of replies you get to a comment and the direction of sentiment that it provides. Perhaps people respond to the thoughtfulness of a comment instead, or something else that doesn't have to do with sentiment. Just in case you were wondering, are there any relationships that are out there that are actually strong in a substantive way and statistically significant, and what would that look like? Well, let's go take a look here now, down here at perhaps the relationship between the reply count and the like count. And of the number of likes. I'm just changing very quickly, as you can see, once I have this. The approach here. So I can run that right away, and let's see what it looks like. Now, that's a relationship that has some kind of staying power. Most of the likes and replies are very low, but there is a positive relationship that as the number of replies go up, the number of likes tend to go up too. And both are indications of the interestedness or interestingness of a comment, that people want to reply to it, and they also kind of like it. And there's an adjusted R-squared of 0.67, indicating about 67% of the variation in one of these variables is explained with variation in the other one. So that is something that is a little bit more interesting in terms of some kind of relationship that we might look at. But let's continue on now very quickly, and let's look at a different set of data. I'm going to erase all these plots for now. And I'm going to erase the console, and I'm going to leave this the YouTube script, saving it, of course, and I'm going to head over to Reddit semantic data. So let's take a look at this second script, in which we're working with a slightly different set of packages. Instead of working with Vosen SML and Tidyverse, we're working with Reddit extractor, a different package to extract Reddit data. And as you can tell by looking in the comments to this video, there is another video that I've shot that will describe how you can get that Reddit data out very quickly. And the process is described in this material that I've commented out, which means it doesn't run. And it's just text to stand there and remind you of what's possible. But I've already done that material. As you can see over on the right, I have two data sets called Tar Heels Threads, which is a set of URLs, web addresses for posts inside the subreddit Tar Heels, which is about the North Carolina Tar Heels at the University of North Carolina. And then a second data set that goes to each of those URLs and extracts information about the comments. So let's take a look at those comments. I'm going to double click in the upper right, but that's the same as the comment or command view Tar Heels comments. And now it's going to show that there are two sub areas, one with the threads again of URLs and another with the comments, and furthermore that there's a field of content in there that is in the comments area, which is the particular comment. And you can see that there's some special characters and things which are a little strange, but we'll convert that to UTF, Universal Text Format, and then we'll proceed from there. We could also view that by looking at the comments sub data set, and then in a nested set of dollar signs, look at the particular sub-element comment if we wanted, or we could take a look at the entire data set. So we can see that there's a timestamp here, a date stamp, the name of the author, a score, which is essentially the number of upvotes, as you can see. And then there's the comment here, which is really what we're interested in today. So let's exit out of that data set and head back over here. Once we're able to access that information and make sure that it's in a readable text format, let's do that. We're going to use that same encoding to UTF-8. We're just copying that information over. It's going to look exactly the same. Then we're going to run the tar heel sentiment analysis for Reddit. The command is the same. The only difference is the name of the data set that we're looking at, which is Tar Heel's comments, the particular sub-data set comments, and within that, the particular column comment. And then we're going to create a data set that combines the general data set on comments with the sentiment that we created in line 17. And then, frankly, we can create very similar histograms and scatter plots and hex plots of density where the commands are going to be just exactly the same. The only difference is the set of possibilities for analysis. If we look at Tar Heel data set, for instance, we're going to see the particular elements that we can grab from Reddit. So there's a score rather than a like count. And that's fine, right? And then on top of that, we have a word count, which is generated by the sentiment analysis. So why don't we take a look at that and see what word counts are like and whether something with more words has a particular sentiment associated with it. It shouldn't, but you never know. We certainly could take a look. And why don't we do that right now? We'll run it, working with the data that I already obtained. And we'll just run that all. It doesn't take very long, as you can see, to think through a different data set running the same commands that we've already set up, which is really quite nice. And now we have a series of plots. We can always scroll through the plots using the arrows in the lower right-hand corner, the arrows at the top of that window. So we've got ourselves observations that start with a histogram. Again, this is very similar. It tends a little more slightly to the negative, but really overall tends almost as positive as the YouTube data. There's no discernible pattern of sentiment by date, which is something that you might expect when there's a game. Although it's interesting to note that there's a number of more posts on a particular day. Perhaps that was a game day. Is something that we might want to look into in greater detail. And then here's your scatter plot by the comment score, which just shoves a lot of those dots together. And let's replace that with a lovely density plot, and then a description of, again, a lack of a relationship. Here's sentiment by the word of count of the comment. The more words there are, does that change the overall sentiment? It shouldn't, because unless perhaps people who are really happy tend to write more. But we don't see any significant relationship. That's fine. But as you can see, when you are looking for relationships between variables, it's not that hard to do. The third example I want to look at today is with something that's a little bit more substantive and a little bit less based simply in process. So let me clear out these graphs. And let's take a look at a bimodal semantic network. And to do that, I'd like to actually show you what this looks like. It's going to be a bimodal list, and it's one that I generated from a non-monogamous subreddit group for non-monogamous people. And I was interested in obtaining a description of how individuals felt about particular combinations of sexual identity and gender identity. And to begin with, for this really beta version of the idea, I looked at just 4 positions. I looked for references to bisexual man and bisexual woman and heterosexual man and heterosexual woman. Clearly, there are more gender identities than this, and there are more sexual identities than this. But this was a good place for me to start. And what I then did was to take a look at attributes that were used to mention those sorts of people. So, for instance, in row 2, bisexual man is referred to as kind in the set of posts that I collected twice. Once a bisexual man is referred to as beautiful. And a bisexual woman is referred to, going down to row 15, as angry twice. So this is in the form of an Excel spreadsheet, but I've saved it as a CSV file, commented delimited file, because that's easily read by R. It's important to note that. And then I have a command here to read that data in, read.csv. The option file choose with empty parenthesis says, let's load it up and you get to pick the file. That way I have a general script that can work with any file of that format. And then it's going to create that list network, understand that it's list data, and it's going to try to generate a graph data frame. So that's wonderful. Once I have that, I'm going to have a network, okay? And I could simply plot the list network using one of the packages I have here, iGraph, right? But, you know, when I do that, and I select my format, I'll get a sort of ugly piece of work. You know, I could gussy it up by you know, making the vertex size a little smaller, because and let's set that to 0 as a matter of fact, because the orange dots don't mean anything. It's the words that do, and we could set the vertex label to a point value of 0.8 to make them a little smaller, and then we could get another plot in there. And I've done that in a previous video. So this is water under the bridge. And it's kind of interesting from a semantic point of view, because it shows us that there are some words that are associated with only one of these positions, some that are only associated with 2, and that the one that has most commonalities with others is the position bisexual woman. That's interesting as far as it goes, but each of those words that is used to describe each of those positions has some kind of sentiment associated with it. Insecure, unfair, guilty, safe, kind. Those words mean something. They mean something really meaningful. So I'd like to not only just plot this as a kind of a monochrome network, but I'd like to show where the positive sentiment and the negative sentiment lie. And so what I need to do is I need to get the sentiment of those words, which are the labels of the nodes. I need to get the labels of the nodes, and then I need to run a sentiment analysis on those words So it'll analyze just the single words and decide whether they're positive or negative. And then I need to attach those sentiments back as properties of the nodes in the network. And then I need to plot it, and we'll need to color code it. So this is a little bit involved, but you're going to get to see at the end what we get to do. So let's call the variable word names. Just it's a placeholder for what? For the stuff we obtain when we run the command get vertex attribute. We're going to get some information from each of these vertices, which is the name that R uses for nodes, or that iGraph uses for nodes. Okay, so that's the attribute that we're going to get. And then if we wanted to, we could then take a look at word names. Okay, and see what we get there. Okay, let's do that, and let's run it and see what we get. Run the selected lines. Okay. So see, we got here an ordered list of the names of the nodes. In fact, we should call them, we should have called them something else like node names, but I'm not too worried about that. So now that we've got that, what do we want to do with it? Well, in order for, this is a little bit silly, but we have to mess with format. We need, if the sentiment analysis package is going to work with it, it's expecting not just a list of words, but it needs to be turned into a data frame, into a database, in other words, a classic database format. So we're going to tell it, hey, look, this thing really already is a data frame, okay? And let's recognize it as a data frame, as a database of what? Of the of that object word names, okay? Then we can finally, let's get the word sentiment, the sentiment for each word. And to do so, we're just going to use the command analyze sentiment again. Now notice I'm using a capital S. Why? Because the command is listed as that. Always pay attention to word case. And we're going to do that with the word names data frame. Okay, so let's run those commands now. Well, we'll go ahead and do that. And then let's take a look at the word sentiment. Okay, so let's just run this whole thing from the beginning again, just to make sure. I'm going to clear everything out, that we've made good progress. And again, it's going to ask me for the file, and that's a CSV file. Okay, wonderful. Oh, and it's all done. It's all there already. So we have our monochrome plot so far, because we haven't color-coded things yet. But we also have now a lovely sentiment analysis for each of those words. Great. And if we take a look at it a little more thoroughly, we'll notice that there are lots of different values, right? There are all these values for the financial networks, which I'm not interested in. I don't want to know about financial dictionary terms. I want to know about sentiment from the general inquirer, which is a combination of the positivity and the negativity. I want that variable sentiment GI again. And you'll notice most of these sentiments are either positive or negative one, with a few 0.5s. The 0.5s happen when you have a two-word phrase, which is just fine. And the ones are positive single words, and the negative ones are negative single words. There are zeros, which are neutral words, according to the Harvard 4 dictionary that's part of the Sentiment GI larger dictionary. So things are proceeding well. I've got those sentiments. And now, rather than binding them to a data set, I want to bind them to a network. And the way to do that, to give a network the nodes a set of properties, it's silly, but it's true. It's just the command V. The vertices of the list network are going to have a characteristic. What characteristic? It's a subclass of things. We're going to call it sentiment, and we're going to want to color them, so I'm calling them sentiment color. And then, again, in order for, we had a list and we turned it into a data frame. Now for the network to understand it, it needs to be turned back into a list. So we use the command as.list for what? The word sentiment, but not just any old part of word sentiment, because you remember you're looking at it now. It's a pop-up window. It's showing many variables. We want the subvariable sentiment GI. Okay. Wow. Okay. Oh, and we've already taken a look at word sentiment, so I can delete that up there. So once we have that, I think we're ready to plot. We're going to have some zeros, negative ones, positive ones, 0.5 values when there's a phrase with two words. But we need to take those now and convert them to color in a plot that looks very much like this. So let's start with a plot that looks very much like that. List network. We'll take the vertex size equal to 0 again. We'll take the vertex label, and CEX is just something you add to 0.8. So it's making it smaller. 1 is standard. We're going to make it smaller so we can look at them a little more when we do what? When we zoom in, right? We want to be able to read most of them over one another. As a matter of fact, we could go all the way down to 0.7. Let's try that. And then we need to somehow code for the vertex label color, right? Because these words are the labels for the vertices, for the nodes. And the option there is called vertex label.color, and that's good. But we want to set a set of conditions, okay, right? And the way to do that is with an if-else command. So let me put this on a new line. And what it is a set of conditions. And it basically says, if this happens, do this thing, and otherwise do this other thing. So we're going to have 2 rounds of this. So we're going to start by setting the vertex label color to if-else. If what? Now we need in the parentheses some kind of occurrence. And what is the occurrence? Well, if that thing, the vertex characteristic for what network? List network. And what sub characteristic? The sentiment color, right? Which we set in line 20. If it's negative, which means what's negative? Less than 0, then let's make the vertex color red. Oh, look, there it is, red. And then, if it isn't that, then we still have 2 other possibilities. We have neutral and we have negative, right? So let's do a further. Then if the second thing to happen is what happens if it's not less than 0. So that means it's 0 or it's positive. So if it's 0 or positive, then we're going to set a second if-else command, which means that if that this thing, this characteristic of the list network, but particularly of the sentiment color, if that is bigger than 0, then let's make that, what's a positive color? I don't know, blue or green. We could go with green. Or, yeah, that's nice and visible, nice and green. And then, if it's neither of those things, we haven't had it less than 0, and we haven't had it greater than 0, well, then it's 0. So let's just set that to black. And that'll be our neutral color. Okay? Whew. Maybe I should put that on another line right there. Right? So that everything, all fits in one place. 'Cause there's our script. Hopefully I haven't made any typographical errors. And let's run this thing and see what happens. Okay, so we're going to need to call up our data again. Oh, I did something wrong. What is word sentiment? It's missing an underscore. I just put the two words together without an underscore. So now I fixed it. No worries. And I'm going to run that again. Let's run the whole thing all over again. And pull it up. I always have typos. Ooh! Okay, that's visible. Let's zoom in and let's take a look. I don't like that color of green. I probably would fix that in the future, but because it's a little hard to read with contrast, maybe that blue would have been nicer. But what we can see here is a set of terms, okay? So first, interestingly enough, we have heterosexual man here, bisexual woman here, bisexual man here, and heterosexual woman here. First, where do we see most of the red with the women? Bisexual woman and heterosexual woman in particular has a lot of red. Where do we see the green? Most of it, not exclusively, but most of it is with the heterosexual man and the bisexual man. And the heterosexual man doesn't have any red. Bisexual man has a little bit. Bisexual woman has a fair amount of red with just a little bit of green. And heterosexual woman is really dominated by red. There's sentiment for each of these positions in the content of the comments that I've read so far. This is a small set of comments. Please don't take it as fully indicative, but it's certainly suggestive. And it shows something about each of these positions in a visual way immediately that is not quite as visible, even if we zoom in, with a monochrome kind of approach. Running a sentiment analysis to show where the approval lies and where the disapproval lies can possibly tell us quite a lot. All right, now it's your turn. I'd like you to give this a shot. I'd like you to try to create some version of the analyses that I've run, and to do so with your own data about a subject that you care about, and that you're trying to gain some new insight about. Best of luck.